Hello and welcome back to my ongoing restoration of a Philips entertainment console. In my previous video I started with a quick overview inspection and quickly discovered that the turntable was a bust and the cabinet's going to need a little work. After opening it up I was surprised by how little there was inside and I ran into my first problem.
Warning, 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 warning.
Heavy metal contamination. So I decided it was best to strip the chassis down and repaint it. And since I was in the garage anyway, I decided I might as well do all the cabinetry work at the same time. Now let's see what I get up to in episode 2.
Perfect. Alrighty. So here is the schematic.
Fortunately, the schematic was readily available, and I'll put a link to where I found it in the description. The schematic is laid out in 3 sections, each corresponding to one of the circuit boards. On the right here we have the audio frequency section. On the top left section we have the AM mixer oscillator and the AM IF amplifier and detector. And on the bottom left we have the FM mixer and oscillator. Like I said in my first video, I was a little disappointed on what was inside this console model. I was mostly disappointed not to see a power transformer and only 2 measly little putt-putt single-ended output transformers. 5 valves and a hot chassis is all this radio really shares with the old All-American 5. Looking closer at the power supply system, you can see that there's a single diode, then 1, 2, and 3 50 UF caps that provides about 130 volts DC into the heaters of valve 4, 5, 1, and 2. Hence the odd combination of 50 and 19 volt valves hooked up in series. The audio section is very simple with 2 mirror channels, starting with a low-pass tone stack, then a volume pot, a triode amplifier that feeds into a power pentode, and then a single-ended output transformer. The only odd thing to note is that the impedance is 10 ohms, which is really odd. Usually you see 4, 8, or 16. Moving now over to the AM section of the radio. In valve 1, we have a heptode side, where the incoming AM radio signal is amplified with the beat frequency coming from the triode side of V1. The rest of your AM section is just your standard IF cans. The only odd thing we find later on is that the IF amplifier and detector tube, V2, is a pentode diode versus the usual triode diode. The FM section is actually spread across 2 boards, with its tube a simple dual triode that is acting as both the IF amplifier and the FM oscillator, plus a number of diodes and other cans that are found on the other board. And that's your basic overview of the radio.
Quick look at the board. Of course, these are the can caps. That there is a resistor, from what I can tell. That's an old diode there. I might swap it out for a new diode. I have to check. It's a germanium piece of junk. It's just a single rectifying diode, so I can change that one out. There's a cap here that definitely has to get changed. That's definitely bad. Swap that one out. And of course, the big nasty thing is on the back side is all this leftover solder. Just tons of it all over the place. It's all done by hand, of course, but I think they would clean it up a bit. You can also see the you can also see it's a little discolored where the tube is here and here. Anyway, that's the output. This is the RF board. Again, just lots of gunk on it. Again, some weird European style caps. Those are double grounded caps. Cool. They did spend time and put a piece of board there to protect up to isolate the cans in here. So it's probably got really good reception. And again, lots of crap all over the place. Ugh. Definitely have to clean this up. That's the off the aerial. Lots of funny looking cans, variable caps, cans. I imagine I could put this back without any problem. There's a 8 farad electrolytic, 350 volts, 8 UF. I don't know if I have any of those, but I can swap that out for some of that. I have lots of 10 volt ones, which would be the same, I think. An inductor there, probably a coil for something. Again, all those silly test points all over the place. Final board is the variable capacitor. You can see it goes up and down, which is really weird. You have to clean this up, it's really dirty. I'm not going to bother opening that, don't want to get it more dirty than it already is. A little more grease on there, I think. Clean out the bearings. It's been factory sealed there, so there's no sense in even trying to redo this one. But I like that. Gotta love those caps. Zoom in here. It's plunge caps. It is so cool. So the capacitance is by the inputting and outputting of the plungers, whatever it is. Sort of like a reminiscence of an old reminiscence of the a nuclear pile, you know, had to drop the carbon rods or raise the carbon rods. I guess it's on both sides. Maybe one is for the AM and one is for the FM. Nicely ganged anyway. Not something you want to take apart. I have no idea what's under here. It does come apart. Don't dare look in there. There's probably nothing interesting in there that I could worry about. Before I even get started cleaning, I have to give a bit of a word of warning. See here, there's still lots of that chromate dust all over the place. So, take hazmat precautions. Use a little of this parchment paper. You steal it from your wife or significant other. This is baking parchment paper. It's somewhat absorbent. And the other most important thing when you're doing that, you don't want to breathe the dust in. So, COVID-19 was useful for something. Put your mask on, and then you just brush it off, basically. Must have been very afraid of this thing rotting in funny atmospheres. Anyway. What next? I'll put a little grease on that before I put everything away. But that looks pretty clean now. Don't see anywhere else. And you can see there's little bits all over the place down there. Let's get the next one. Ooh. This board. I think we'll get the old flux cleaner out on this. Board's cleaned up nicely. Now what I'm going to do is just take off the electrolytic caps. This cap here is obviously not going to be any good. These might reform, but they're pretty odd. They're 200 UF at 200 volt, 50 UF at 200 volts. They're expensive caps to replace, so it's getting more and more expensive every day. Let's see, there's one 8 UF there. That's an easy one to replace, and one there that's got to go. Again, the board cleaned up nice. There's still some stuff down there on this side I'll have to clean up on the next, when I finally get around to it. But the old solder sucker is heating up. It shouldn't take too long now to go through and take these things off. So I managed to get the first two off fairly easily, but as you can tell, zoom in here, the bottoms don't look pretty good on them. They look like they're leaking. Just looking close at the next cap, if you look right in there, it's something pokey. Look how bad a solder job that is in there. Next to Alan Bradley. Huge big blob sitting right up there. Yeah. All the electrolytics. Leave these cans alone. No idea what that is. I wonder what this is over here. Resistor probably, or an inductor maybe? Inductor? Nope, 2 nanofarads, a cap. There's the inductor there. Probably the oscillator coil. Another oscillator coil. You know what they say about FM radios. 3 rules of FM radios. Never realign an FM radio, never realign an FM radio, and never realign an FM radio. Okay. Alright. Time for the great recapping. So I had a look at it, even though it's not a particularly good circuit. The caps are cheap, I had a bunch of these. I'll just recap it, and if it doesn't work, I'll decap it. There's a trick to start off with. Yeah, see? This and this are the this and this are the outer ground, but these two, the trace isn't connected to there. I'm gonna ohm that out and see what it is connected to. Yeah, so let's see here. Yeah, it's an isolated trace. Aha! So I either got to put a jumper wire across or get everything through that 1 hole over there. I think I'll just go through the 1 hole. Alright, just carrying on. I've got my 2 8s in there. Then I've got this funky one over here. Now if you look at the Schematic, it is here somewhere and it says 3.2 at 64 volts. And this was 4. And I got a 3.3 at 100 volts. So it should be all okay. And believe it or not, that's the capping out. It's one of the quickest uncappings I've ever done. Cool. Okie dokie. That's going, that's going. So I was just checking the continuity of everything to make sure I put everything back correctly. And I'm on the wee one I put over here, and that should be positive, but it's not. The positive's over here, which is the same as this, and that's the negative side of that cap. So this one is in wrong. Oh well, you always make one little goof. Time to get the solder sucker out and stick that in there correctly. Now to put all the pieces back together again. Of course, putting this thing back together is just the exact reverse of taking it apart. The only problem is I lost a wire somewhere along the way. I don't remember where this one hooked up to. It popped off. I think it was one of the power boards over here. But I took lots of notes, so I should be able to find where that goes. First thing I took off were the pots. And I'm not sure where they go back in. I know they go there, but obviously they don't go that way because the caps are on the wrong side, so it must go in this side. That's when, if you don't know which way they go, you get out your notes. Need a new cap in there. Look at the size difference. That's the old one, which we'll just take out, and that's the new one. Talk about scaling back production. It's a nice Mallory cap, but no sense in leaving that in there. It's showing signs of aging up here. Okay. Positive. Side. You know, before you put anything together, always check your box for more parts. I forgot to put this in, which is the insulator for those. Well,
I think I'll just let Gunny take us out on this one. The rest of the video is really just me looking up where wires go and then hooking them back up. Keep an eye out for the next episode. I promise that one will be a little more interesting. TTFN!
I'm in heaven, and my heart beats so that I can hardly speak, and I seem to find the happiness I see when we're out together dancing cheek to cheek. Heaven, I'm in heaven, and the cares that hang around me through the week seem to vanish like a gambler's lucky streak. When we're out together dancing cheek to cheek. And I love to climb the mountains and reach the highest peak, but it doesn't thrill me half as much as dancing cheek to cheek. And I love to go out fishing to a river or a creek, but it doesn't thrill me half as much as dancing cheek to cheek. So come on and dance with me. I want my arms about you, the charms about you that will carry me through heaven. I'm in heaven, and my heart beats so that I can hardly speak, and I seem to find the happiness I've seen when we're out together dancing cheek to cheek.
Now, one thing you do when you're done doing this is you flip her over, you give it a good shake. Ugh! Make sure you didn't get any crap stuck in there. The Apollo Shuffle. They do that on the spacecraft. They didn't do it on the first couple. They left a bunch of screws and nuts lying around inside. See, there's one there. That one didn't fall off. Okie dokie. Besides that, she's looking good.